Okay, we are reviewing for test 2, and I'm kind of picking up where I left off from the first period. And I'm going to try and get through the entire review. I won't be able to do every single problem just because of the time constraint, but I'll try to sample the types of problems that will be on the test. So in section 1.8, we are covering higher order derivatives. So let me just jump to the review. And here we are. A higher order derivative is when you take the derivative repeatedly. So here's an example. We're given a function y equals 7x squared plus 5x minus 5. So we have this function here, and we are going to find d squared y dx squared. So let me talk for a moment. What does that mean? Okay. D squared y dx squared is a way of saying the second derivative. So the first derivative is dy dx. Okay, and taking the derivative of this polynomial, we apply the power rule, and we have 2 times 7 is 14x plus 5. Okay, so this is dy dx. This is the first derivative. If I take the derivative of that, I get d squared y dx squared. And the derivative of 14x plus 5, this is a linear function, so it would just be the slope. The derivative of a linear function is its slope. So there we have, it's 14. There we have it, 14. Okay, same thing here. You just take the derivative twice. Okay, so I don't want to do all of these problems since they're so similar, but I mean, just real quickly, if you take the derivative here, you get 8x cubed, because you take 4 times 2, minus 4x, and of course the derivative of 8 is 0. So you get 8x cubed minus 4x, and that's not the answer. You have to then take the derivative of that. So 3 times 8 is 24. Subtracting 1 from the 3 is going to be 24x squared. And then here, minus 4x, the derivative of minus 4x is going to be just plain old minus 4. So B is the correct choice. Okay, so these problems are all pretty much the same. I want to do this one here for you because this one practices the quotient rule. Or you could say, you could use the power rule and then the chain rule. So let me show you how to do this one. Here, this one's a little bit more involved. This is number 36. I'm going to copy that down. We get y equals 1 over x squared minus 1. And so whenever you see a constant divided by a function like this, you probably would want to just write it as x squared minus 1 to the negative 1 power. And then if you take the derivative, you can apply the power rule. So dy dx equals negative 1 times x squared minus 1. Subtracting 1 from negative 1 gives me negative 2. And then applying the chain rule, I have to take the derivative of the inside. So I'm going to multiply by 2x since that's the derivative of the inside. So simplifying this, I would have negative 2x over x squared minus 1 squared. Now this is just the first derivative. Okay. To find the second derivative, you would take the derivative again, and this time you would want to use the quotient rule. So d squared y dx squared, you're going to take the bottom function, which is x squared minus 1 squared, times the derivative of the top, which is negative 2, minus the top function, which is negative 2x, times the derivative of the bottom, which is using the power rule, we have 2 times x squared minus 1, subtracting 1, and then we have to multiply by 2x because that's the derivative of the inside, okay? All divided by the bottom function, which is x squared minus 1 squared, but when you square that, you're just going to have a power of 4, okay? So looking at this, since this is multiple choice, you have to simplify the numerator, and you can see that the bottom is x squared minus 1 to the 4th power. So we just have to work on the numerator to match it to our answer here. And so let me do that real quick. I'm going to try to avoid problems like this where you have a messy algebra. So this is probably not a good example for what's going to be on the test, but you can see here. Well, let me just leave it like that. Let's see. I don't want to waste time in our review. So I'm not going to put one that complicated on the test, but that's how you go about it. And this runs into the issue with, I'm going to hand pick the questions so that the algebra is not going to trip you up. So I would not put this one on the test. This one kind of slipped by, but let's just go on. Here, you're just taking the derivative twice, and it looks like I wouldn't put that one on here. That's another algebra issue one. The main ones that I'm going to put on for the second order derivatives would be something like this one here. This is actually a third order derivative, but it's a polynomial. So those are pretty easy to differentiate. What I'm really getting at here for the test is just to know that you know what d cubed y dx cubed, what that means. That's all I'm really interested in. So let's do this one, number 39. We have y equals 5x cubed plus 6x squared minus 5x. And we're asked to find d cubed y dx cubed. Okay, so what does that mean? Well, that just means you're going to repeatedly take the derivative 3 times. So dy dx, taking the derivative of this, we use the power rule. We have 15x squared plus 12x minus 5. So that's the first derivative. Then the second order derivative here, d2y dx squared, is going to be taking the derivative of the first derivative. So that becomes 30x plus 12. And then finally, to do that again, we get the third order derivative, which is just 30. So you take the derivative 3 times, and this is really more what I'm interested in that you can do. Pretty simple, okay? Just be careful because you can see, well, there we go. That one, they didn't, sometimes they try to trip you up in the answers, okay? So here, you're just, because this is a 4, you're just going to do it 4 times. And we just have a simple polynomial here. I'm going to let you do that one. Here, simple polynomial, you do it 5 times. Okay, so go ahead and give those a shot. I don't want to spend too much time on this. One thing you should know is that when you're talking about distance given by a function and you're asked to find the acceleration. So if you start with the distance and you take the derivative 1 time, that's going to give you the velocity. And if you want to find the acceleration, you need to take the derivative of the velocity. So this problem, number 42, let me work this one out. I'm going to copy the function. It's s of t equals 8t cubed plus t plus 4. And taking the derivative once is going to give me the velocity. So v of t is going to be 3 times 8, that's 24t squared plus 1, right? That's the derivative of my position function, my distance function. I get the velocity. And if you want the acceleration, then you take the derivative again. So this is going to be 2 times 24, 48t. Derivative of a constant is 0. So if you look at your choices there, you have C is your correct answer. Okay. And this problem, again, same sort of problem. You can do that one on your own. Okay, here we have a restaurant purchased kitchen equipment on January 1st, 2017. On January 1st, 2019, the value of the equipment was $14,650. The value after that date was modeled as follows. And you can see here that we have a negative. So that is going to be a decreasing exponential function. And it's asking what is the rate of change in the value of the equipment on January 1st. So whenever they ask you for a rate of change, you simply take the derivative. So this is number 44. I'm going to copy this function down. We have V of t equals 14,650 e to the minus 0.167t. Okay. So when they ask you for the rate of the change, you're just going to take the derivative, and they want to know on January 1st. So that would be the start date, I guess. Let's see. Yes, that's on that date, that is the value of the equipment. So what is the rate of change? Here's our function. V prime of t. Okay, we're in section 2.2 now, and section 2.2 is on the derivative for exponential functions having base e. So remember, when you just take the derivative of an exponential function, there are 3 steps, and that's if step 2 is multiplying by the natural log of the base. But since the base is e, the natural log of e is just 1. So step 2 multiplying by 1 doesn't change anything. So I'm not going to do step 2 here. I'm just going to copy what I see. That's step 1. So I'm going to copy this entire function just as I see it there. I'm going to skip step 2 because the base is e. And so I don't need to do step 2. But step 3 was to multiply by the derivative of the exponent. In this case, I'm going to multiply by negative 0.167. That's the derivative of my exponent. So I'm going to use my calculator and multiply 14,650 and I'm going to multiply that by the negative 0.167. And that gives me negative 2446.55. And so I took this number, multiplied it by this to get this, and I still have the e to the minus 0.167t. So this is my rate of change. Okay. And the rate of change in the value of the equipment on January 1st, 2019 was blank dollars per year. And so I'm going to put 0 in for t because we're asking January 1st, 2019, and that's kind of the beginning. So that was going to be negative 2446.55. And then in the next, and let me just explain something there so you can see where I got that. See, when you put t equals 0, which we're using for January 1st, 2019 is t equals 0. When you put a 0 here, you have e to the power of 0. And any number to the power of 0 is just 1. So you have this constant multiplied by 1 when I plug in 0. I'm going to write that out here. I don't want to gloss over that in case you didn't catch that. See, I'm plugging in t equals 0. So I just get this piece right here is equal to 1. And so 1 times this number is going to be negative 2446.55. So that's how you do that problem. That's part A. Now going part B, it says the original value of the equipment. So we're not talking about change here. So in part A, we did the rate of change. That's the derivative. But when you just say the original value, you're talking about the very original function. And so notice here, this, you got to be careful. You have to pay attention to these details because look here, January 1st, 2017. Well, that was 2 years before. So you're going back in time. So now t is -2 because you've gone 2 years back in time. So you're going to take -2 and plug it into your original value function up here. So part B, I'm going to calculate V of -2. So I'm taking 14,650 e to the minus 0.167 times -2. So I'm going to enter that into my calculator. And I have 14,650 times e to the, I'm going to use parentheses because I'm going to do a calculation here, 0.167. The negatives are going to cancel, so I just multiply that by 2, and I get 20459. And if I round it, it's going to be 0.36. They want that, that's in dollars. So there's my calculation right there. So going back to the homework over here, I have 20459.36. Okay, notice that this number is higher than on January 2019. So in 2017, the value of the equipment was higher, and that's because it's depreciating, right? Or I think that's the right word. It's going down in value as time goes forward. So that's why we have a negative number here for the rate of change of the value. It's going down. Okay, so you can expect these type of questions. Not a lot. Most of the questions on the test is just calculating the derivative. But here it's in the context of a word problem. But it's, again, since this is a derivative test, in the word problem, you're going to have to calculate the derivative. So just look for the word rate of change. That's what it means when you say rate of change. You mean calculate the derivative for the function. Okay, whoops. I didn't mean to do that. Hold on. Going back. All right. There will be a question like this on the test. Remember, we had a question like this on the first test, and I had mentioned that every time you take the test, you're going to have something where you have to find the equation of the tangent line because it's such an important concept in calculus. So I put it on every test. So this time, because we're talking about exponential functions, the function given to you is an exponential function. And what is an exponential function? It's a function where the exponent is a variable. So we are given this function g of x equals e, that's a constant, approximately 2.7 to the power of -5x. The exponent is a variable, and we want to calculate it at the point 0, 1. Now, the first step in doing these tangent line problems is to find the derivative. So I'm going to do that here for this function. And to find the derivative of an exponential function base e, you copy what you see. So it's just e to the -5x. And then you multiply by the derivative of the exponents. We're going to multiply by -5. And so it's going to be -5e to the minus 5x. This is the derivative. You want to evaluate that at the point 0, 1. So that's step 2, and that's your m, the slope. So when you plug in 0, you're going to get -5 times e to the -5 times 0. Well, this is 0. E to the 0 is 1. So this is going to be -5. So this is your slope. Step 3 is to find b. Okay. So b is the y-intercept. And in this particular problem, because x is 0, this point lies on the y-axis, and therefore this is the y-intercept. And so the b value is 1 because that's the y value there. So b equals 1 since 0, 1 is the y-intercept. All right, so we found the slope and we found b. So the tangent line, and that's step 4. Remember, you have the formula for a line is y equals mx plus b. So you just plug in the m is -5 and b is 1. So it's going to be +1. Y equals -5x plus 1. And okay, so like I said, there will be a question like that on the test. Now we're getting into the derivatives of the natural log. So this is section 2.3. Number 46. F of x equals 11 times the natural log of x. Okay, so basically the whole test is on differentiation. So when it says differentiate, that means find the derivative. So we're given a function f of x, and we just need to find the derivative. So the way you find the derivative for log functions, there are 3 steps. Step 1, take the reciprocal of the inside function. Step 2, multiply by the 1 over the natural log of a, where the base is a. Okay. For step 2, we don't do this step for the natural log function. So this is a general description of how to take the derivative of a log function, but when it's base e, which is the natural log, has base e, you skip step 2 because the natural log of e is just 1, and multiplying by 1 doesn't change anything. So for this problem, we're going to skip step 2. But step 3 is to multiply by the derivative of the inside. And we're also going to skip this step because it's just plain old x. There's no, the derivative of x is just 1. So that's not going to change anything either. So this is a real simple problem. We just have to do step 1. And so the derivative is just simply 11 times 1 over x. You just take the reciprocal of the inside. The inside is x. You take the reciprocal. And so the derivative is 11 divided by x. Okay. So, you know, it makes sense that you're starting off with some really easy problems. So this one is just 11 divided by x. Okay, now here, notice that we have a product here. We have the natural log function, and we know how to take the derivative of that, but we also have this x to the fourth, which is a power function multiplied, two functions multiplied. So let me go ahead and do this one. This is number 47. And we have f of x equals x to the fourth multiplied by the natural log of 9x. Okay, the product rule is, so we have a product here. We have the first function, we'll call it f, not the same f that this f, it's a different f, but this is the formula, so I'm just using f because that's how the formula does it. So you take the first function times the derivative of the second plus the second function times the derivative of the first. So f prime of x, the first function is x to the fourth. The derivative of the second function, this is a log function. The derivative, the first step is you take the reciprocal. So we multiply by 1 over 9x. Then you multiply by the derivative of the inside. Step 2, we skip because this is the natural log. So the derivative of the inside is 9. Then you add to that the second function, which is the natural log of 9x times the derivative of the first, which is 4x cubed. Okay, so you can leave it like this. Or if it's a multiple choice question, you want to match it. So here we have the 9's cancel, and we have x to the fourth divided by x is going to be x cubed plus 4 times the natural log of 9x. And then we have an x cubed in there also. I'll write that there. Okay. X cubed plus 4x cubed times the natural log of 9x. All right. So I'm going to go ahead and enter that in. And like I said, you don't have to simplify it if it's a non-multiple choice question. So that way I can see that you understand the rules that you're applying. That's the main thing, is to know the rules. Yeah. Okay. Don't be tripped up by these problems that are word problems. Let's read this. Okay. Students in the zoology class took a final exam. They took equivalent forms of the exam at monthly intervals thereafter. After T months, the average score S of T as a percentage was found to be given by this equation here, where T is greater than or equal to 0. And then you're supposed to complete all these parts. Well, the first part says, what was the average score when they initially took the test? So this function is the average score. And then when you say initially, that's the starting point. So that's when T equals 0. Okay, the time is 0. We're just starting. So all you're going to do is plug in 0. And if you do this on your calculator, you'll see that natural log of 1 is 0. The log of 1 for any base is always 0. So this piece is 0. So the answer is just going to be 73%. And it is given in as a percentage. So part B, what was the average score after 4 months? Okay, so now T is in months. So we're just going to say T equals 4. So now we're just going to take 4, and they say round to 1 decimal place. So we're going to use our calculator. We're going to plug in 4. So we're going to get 73 minus 17 times the natural log of 5, because we're taking 4 plus 1. So let me go to my calculator. So 73 minus 17 times the natural log of 5. And it said to round it to one decimal place, so it's going to be 45.6%. Let's see here. Going back to what did I say? 45.6. I think that's what I said. Okay, and part C, what was the average score after 24 months? So you're just plugging 24. And so this time you're going to have the natural log of 25 because you take T is 24 plus 1. So, whoops, going to the calculator, we have 73 minus 17 times the natural log of 25. And rounding it gives me 18.3. And finally, oh no, not finally, they want you to find the derivative of this function. So that's kind of getting down to the main thing here, finding the derivative. So let me copy the function down and I'll show you how to do that. Let's see. I think I got that right. Okay. So here's our function. We're going to take the derivative. Of course, the derivative of a constant is 0. So we basically are just taking the derivative of this natural log function. So you take minus 17 times the reciprocal of this. So that's going to be 1 over t plus 1 and times the derivative of the inside. Well, that's just 1. So this is your derivative, minus 17 over t plus 1. Okay, and so then finally, they want you to calculate the derivative at 4 and at 24. And so that's just plugging it in. If you plug in 4, it's going to be negative 17/5. And which means after 4 months, the average score is, well, since it's negative. So if the derivative is negative, that means the function is decreasing. Okay. And then when we get to 24, it's decreasing by 17/5 points a month. So the negative shows you it's decreasing, and then this value shows you the amount by which it's decreasing. Then you do the same thing for 24. You're going to have negative 17/25. And it means after 24 months, the average score is decreasing again because it's still negative but this time it's decreasing by 17 over 25, that amount, okay, a month. Oh, I must have messed something up.
I think it looks like simplify, because when I did it, I simplified it, like a decimal answer.
Oh, they want a decimal answer?
Yeah,
Okay, I'm not going to take that time to do that. The main point is that it's decreasing. If you were to enter it in like this, I'd give you full credit if it's not in the right. Oh yeah, type integers or decimals. Okay, I don't want to waste the time to do that, but I would give, if you put it in fraction form, I would take that as give you full credit for that. Okay, moving on. Now we're moving into section 2.6. This is when you differentiate a exponential function which does not have base e. So this is number 49. And we have y equals 21 to the power of x. So we're differentiating an exponential function, and the steps for differentiating an exponential function are, and I'm not going to take the time to write them down, I'll just say them. Step 1, you write it, copy what you see. Step 2, you take the derivative of the exponent, and then, or that's step 3. Step 2 is to multiply by the natural log of the base. In this case, the base is 21. So let me just quickly show you how to do that. So the first step to take the derivative is just copy it just like you see it there. Then the second step is to multiply by the natural log of the base. The base is 21. And then the third step would be to take the derivative of the exponent and multiply. But since this is just x, the derivative is 1. So we don't do that step for this particular problem. And so there you have the natural log of 21 times 21 to the x. Okay. Here's same sort of problem. I'll let you do that one. Same, find the derivative, same sort of thing. You just copy this exactly as you see it. So 7 times 5 to the x, and then multiply by the natural log of 5. So it would be 7, and then you want to make sure you use their dot, because I'm not sure if you just wrote 75x, it would look like 75, and so you want to separate that. So then you let's see here. You're going to, whoops. I lost my little, let's try again. So 5, 7, 5 to the power of x, and then times the natural log of the base. The base in this case is 5. The base is always what's under the variable. So the base is 5. Okay. Now this one is, again, you have an exponential function. So this is a really good example where all 3 steps are involved. So let me do this one. This is a good example. We have y equals 11x to the 6 plus 2. So you're going to 3 steps. This is an exponential function. First, you have to recognize that it's exponential. Why is it exponential? Because the variable is in the exponent. That's what qualifies it as an exponential function. Once you've identified that you're dealing with an exponential function, the 3 steps are, let me go through those as I differentiate this. First, you copy what you see. So you have 11x to the 6 plus 2. The second step is to multiply by the natural log of your base. In this case, the bottom underneath the variable is 11. So you multiply by the natural log of 11. And then step 3 is to multiply by the derivative of your exponent, which is 6x to the 5th. So those are the 3 steps. Step 1, step 2, step 3. Make sure you know how to do those. But first, you have to identify that it's an exponential function. So we have 11 to the power of x to the power of 6 plus 2. That's the first step. Then the second step, I wonder if I could just write natural log of 11 here. And then you've got to be careful because you probably want to put parentheses around it because you don't want to, you want to distinguish, whoops, sorry, natural log of 11. You want to distinguish that from multiplying by 6x to the 5th. So make sure you practice entering these in because you want to make sure you enter it in correctly. So that looks good. And again, I will check all your answers. If you have parentheses out of place or something, I will give you credit. So don't worry about it if you don't get it exactly right. Okay, now section 2.6, we are differentiating log functions. So there are also 3 steps. The way you identify a log function is it says log or it says ln. ln is shorthand for log base e. So this particular problem, we have log base 6. And so the steps are so this is number 53. The steps are y equals log 6x. You take the reciprocal. When you're taking the derivative, you take the reciprocal of the inside. So the inside is just x. So the reciprocal of that is 1 over x. Then you multiply by the reciprocal of the natural log of the base. That's step 2. And then step 3 is to multiply by the derivative of the inside. Well, that's just 1. So we don't really have to multiply right there so you can see what's going on. And we just have 1 over x to the natural log of 6. So step 1, step 2, step 3 for these log functions. Oops, ln 6, I meant to write. There we go, that's better. Okay. Don't be bothered again by the fact that this is a word problem. For whatever reason, students often, when they see words like that in a problem, they're just terrified. But remember, this is a derivative test. So when it says find the rate of change, that just means find the derivative. And in particular, it says at the time t equals 3. So in that case, you're just plugging in 3. So here we have, let's see, this is 54. S of t equals 110 minus 40e to the negative 0.5t. Okay, so I'm going to take the derivative of that because they say find the rate of change. So first I'm going to take the derivative of this function here. The derivative of a constant is 0, so I'm really just taking the derivative of this piece right here. So since this is exponential, I copy what I see, negative 40e to the minus 0.5t, and then the base is e, so I don't have to multiply by the natural log of the base because that's just 1. But then I multiply by the derivative of the exponent, that's step 3. So in this case, it's negative 0.5. And 0.5 is just 1/2. So 1/2 of 40 is 20, and then I have a double negative, so it's going to be positive 20 e to the minus 0.5t. And then they want you to find that rate of change when t equals 3. So I just plug in 3, and I'm going to use my calculator to calculate this. Whoops, let's see. I meant to do the calculator. There we go. All right, so we have 20 times e to the power of negative 1.5. And we get 4.46. So plugging that in. What did I say? Negative 4.6. I must have rounded that. What, hold on. I forget what I said. I'm just going to look and make sure I got the right thing here. Oh, they wanted it rounded to 1 decimal place. So that would be 4.5 and not negative. I don't know where I got the negative, but it's positive 4.5. So right here, D is the correct answer. Okay, so again, if you see like this, if you see a word problem, don't let that trip you up. You're just going to take the derivative because they're asking for the rate of change and then plug in the 8 there. In this case, it's t equals 8. And you've got your, these problems are multiple choice. I'm not sure what they are on the test, but if you make a mistake, you know, you can kind of check your answer that way. Same thing here. Take the derivative because they're asking for the rate of change. And this one, they want you to interpret the rate of change. So after 4 months, notice here that when your derivative is negative, it's decreasing. So you can see here they're talking about it's decreasing. And is it the daily attendance or is it the change in daily attendance? It's the daily attendance decreasing because, and this is the amount by which it's decreasing. So anyway, give that one a shot. Here's another one, same sort of thing. They're asking for, let's see, rate of change. Whenever you see rate of change, think derivative. This is a derivative test, so you're going to be taking the derivative a lot. I think I already did one like this. Didn't I do that one? Oh, this is just a multiple choice version of the one I did earlier. Okay, that's all. You can practice that. So all of these, look at this. The X value is 0. So that means the B is 1. Here, again, the X value is 0. So B is 8. So it's actually easier. These problems are a little bit easier. Here again, the X value is 0. So B is 4. They're giving you the intercept. So you don't have to calculate B as you've done in the past. It's a little bit easier. All right. Now we're coming into the multiple choice questions. I've done already some examples like this. I don't want to take up too much time because I want to cover as much as I can. Here you just take the reciprocal. So it's 1 over x minus 5. And the derivative of the inside is just 1. And the natural log of e is, the natural log of e is 1. So it's just the reciprocal. It's just step 1. 1 over x minus 5 is how you do that. All right, let's look at this one. This one incorporates the chain rule. So now the base is e because the natural log has base e. So I don't have to multiply by 1 over the natural log of e because that's just 1. So I'm going to do step 1 and step 3 for this particular problem. I do have to do step 3, which is the chain rule. So when you're finding the derivative of a function like this, you are going to take the reciprocal of the inside. So 7x squared is inside the log function. So you take the reciprocal, and then because this is not just plain old x, you have to multiply by the derivative of the inside. So you're going to multiply by 14x. And then this x will cancel with one of these x's. And so you just have 14 over 7x. 14 divided by 7 is 2 over x. And so on these multiple choice questions, you've got to simplify that because if you look at the multiple choice, you can see there is the simplified version, 2 over x. Okay. On the non-multiple choice one, all you have to do is enter in the original expression that you come up with. You don't have to simplify it, but here with the multiple choice you do. So let's look at this one very quickly. This is number 64. We take the reciprocal because this is a log function. So the first step is to take the reciprocal of the inside, which is 7x cubed minus x squared. So step one in taking the derivative is the reciprocal of the inside. Step two is the natural log of the base, or the 1 over the natural log. We don't need to do that step because this is the natural log function. And then step three is the chain rule. The derivative of the inside is 21x squared minus 2x. And so looking at your choices here, you have 21x squared minus 2x. They must have, oh, I think they factored out an x. So it's, yeah, let me just show you what they did. They did some algebra there. So you can see this has a common factor of x. So I can write this as x times 21x minus 2. And then here, there's a factor of x. So I can pull out the x, 7x squared minus x. So these are going to cancel. So this is what you're looking for, this part right here. So I first tried to see if they had my answer, and they did not. So then I had to simplify it. So you can see here, 21x minus 2 over 7x squared minus x. So it looks like it's B is the correct choice. So if you're good at algebra, you'll like the multiple choice questions. But I find that students don't do as well with too many multiple choice. So I do mix it up. I'm really trying hard to make this a straightforward test. I'm not trying to trip anyone up. So I just want you to practice. That's the most important thing, is practice. On these reviews, some of the questions are really kind of difficult. Don't spend too much time on those, because those aren't the type that I want to put on the test. I really want to keep it as simple as I possibly can. But if you're going for the extra credit, then you want to go ahead and do those, even the ones that are harder problems. Okay, so here, let's do this one. This is a really good example of where you've got a quotient. You got to use the quotient rule and the rules for logs and exponentials. So this is a really good problem. This is number 65. I'm going really fast because I want to try and get to as many problems as I can. Y equals the natural log of x over x to the 7th. Okay, so we know we're going to use the quotient rule because we have a function in the numerator, that's f, and then we have another function in the denominator, that's g. So if f of x equals the natural log of x, the derivative of that is going to be 1 over x. And if g of x is x to the 7th, this is a power function. I said exponential, but I meant power. How do I know the difference between exponential and a power function? Well, with exponential, the variables in the exponent, and with a power function, the exponent is constant. So, keep that in mind. This is a power function because 7 is a constant, and that's the exponent. And I take the derivative, I'm going to use the power rule, 7x to the 6th. And now, because this is a quotient, I have to use the quotient rule. And the quotient rule is just, the quotient rule is the bottom function times the derivative of the top minus the top function times the derivative of the bottom over the bottom function squared. That's the quotient rule. So applying that rule for this problem, I'm going to have x to the 7th, that's the bottom function, times the derivative of the top, which is 1 over x, minus the top function, which is the natural log of x, times the derivative of the bottom, which is 7x to the 6th, all over the bottom function squared. Now, when you have an exponent raised to another exponent, you multiply the exponents. So, and here we have x to the 7th divided by x, that's just going to be x to the 6th minus 7x to the 6th times the natural log of x all over x to the 14th. Now, I'm not sure, they may simplify it further, so let me check their answers. I bet you they're going to simplify it even further. It looks like they did. So notice that we have x to the 6th here, and we have at least x to the 6th in the denominator, so we can cancel those all out. So this becomes 1 minus 7 ln x over x to the 8th, because if I'm dividing out by x to the 6th here and here, if I divide out by x to the 6th, I'm left with 1. Here I'm just left with 7 ln x, and if I take x to the 14th and divide out by x to the 6th, I'm left with 8 of them. So this is my final answer. Now, I don't like this question. I probably wouldn't put this on the test because of all the algebra involved. And I'm going to try to avoid as much algebra as possible. But there you see the answer is right here. So that's how you do that one. Find the derivative of this function. These are all natural log. I'm going to skip these because we've done quite a few examples. We've talked about word problems. They're asking for the derivative, and then they want you to plug in 5. So I'm going to leave that one go. I want to find some, here we go. These are log functions and exponential functions that are not base E. So we're kind of getting to that part. So here we have y equals 5 to the x. This is 68. And when this is an exponential, so your first step is to recognize this is exponential. So we're going to use the 3 steps for finding exponential or derivatives of exponential. You copy what you see, multiply by the natural log of the base, and then multiply by the derivative of the exponent. Okay, so that's as simple as that. I'm not going to end, well, these are multiple choice. So we have ln 5 times 5 to the x. So C is the correct choice. Next question. It's basically the same type of question. Let me skip that one. Same type of question. Well, okay, actually, this one, 670, we're doing y equals 9 to the negative x. Okay, so we're differentiating 9 to the negative x. So it's exponential because the variable is an exponent. So we copy what you see. That's the first step. Copy what I see. So 9 to the negative x, multiply by the natural log of the base. The base is 9. And then multiply by the derivative of the exponent. In this case, it's -1. So you get negative 9 to the negative x, and then natural log of 9, like that. Okay. So it looks like B is the correct choice. All right. Now this one is a product of x and 1.3 to the x. So x is just a linear function, and 1.3 to the x is an exponential. We have 2 different functions here multiplied, so we're going to use the product rule. And it goes like this. It's the first function times the derivative of the second. The derivative of 1.3 to the x is well, I better just do this problem and then we'll look at the answers. I was going to try and do it on the fly, but here, f of x equals x 1.3 to the x. Okay, this is number 71. Okay, so we're going to use the product rule. So f prime of x. The first function is x times the derivative of the second. This is exponential. The derivative, you copy what you see, multiply by the natural log of the base. In this case, it's 1.3. And then the chain rule, we just multiply by 1. So then you add the second function, which is 1.3 to the x times the derivative of the first. Well, that's just 1. So notice that we have a common factor of 1.3 to the x. So we can write this as 1.3 to the x times x natural log of 1.3 plus 1. Now, I don't know what format they're going to have it in, so I'm going to check now and see which one it is. So here's 1.3 to the x plus x times 1.3 natural log of x. It looks like it's right here, D. Okay, let's go through this one. This is an exponential. You copy what you see. So we have y equals 10 to the x squared. Number 72. I like these problems because they're real simple. You just, let's take a look at this, okay? Just first you recognize, oh, this is an exponential function because the exponent is a variable. So the 3 steps are, number 1, copy what you see. Number 2, multiply by the natural log of the base. And number 3, multiply by the derivative of the exponent. There you have it right there. Let's check the answers, see what we can find. And then you can see the 3 steps. Copy what you see, the natural log of the base, and then here in the middle is the derivative of the exponent. So C is the correct answer. See how simple that is? Don't make it harder than it is. I guess the hardest part is recognizing which rules to use. Here, you're going to use the difference quotient. Notice in the difference quotient, you have the bottom function squared. So all of the answers have the bottom function squared, okay? And then the top function, you start with the bottom function x times the derivative of the top. Well, the derivative of 9x is 9x times the natural log of 9. So here you have right here, x times 9x times the natural log of 9. And now you're going to take the bottom function times, the top function times the derivative of the bottom. So the top function is 9 to the x, so you're subtracting that, and the derivative of bottom is 1. So this is obviously the correct answer. I'm going through this really fast, but you can review this when I send you the video link. So don't stress about that. Okay, now we're doing log functions. Log functions also have 3 steps. So I'm going to go through a few examples of these type. So 74, we have log base 2 of x. Okay. The way we differentiate a log function is you take the reciprocal of the inside. Here's the inside of the log. Okay, so you take the reciprocal, 1 over x, times the reciprocal of the natural log of the base, which in this case is 2, there's the base, times the derivative of what's inside. Well, the derivative of x is just 1. So we really don't have to do this step. And so we just simply get 1 over x natural log of 2. And C is the correct choice. Okay, then this is another good example. 75. We have y, or f of x, equals log of x over 2. Okay, so the 3 steps. Take the reciprocal of the inside. In this case, the reciprocal of x over 2 is 2 over x. Multiply by the 1 over the natural log of the base. There's no base here, so this is a good problem to talk about. Let me just make sure I copied that right. When you don't see a base, assume it to be 10, okay? We have the decimal system that we use, so the base is 10, and so just to save time, we don't want to write base 10 every single time, so we just don't write it at all. So whenever you see a log without a base, it's 10. And you can see in the answers here, we have the natural log of 10. So multiply by 1 over the natural log of the base, which is 10. And then finally, you want to multiply by the derivative of what's inside. Well, the derivative of x over 1/2, think of this as 1/2 times x. So the derivative is just the constant 1/2. And you can see the 2's are going to cancel here. So the derivative of this is just going to be 1 over x natural log of 10. All right. Let's do this one. Y equals log 9x. Okay, so you recognize, oh, this is a log function. What is the base? The base is 10. What are the 3 steps for finding the derivative of a log? Step 1, take the reciprocal of the inside, so 1 over 9x. Step 2, multiply by the reciprocal of the natural log of the base, so 1 over natural log 10. Step 3, multiply by the derivative of the inside. The derivative of 9x is 9. You can see the 9's are going to cancel. And so we have 1 over x natural log of 10. That seems pretty familiar, so probably didn't have to do that one. It's kind of repetitive, but there you go. All right, so these are really simple problems. Here you can see, take the reciprocal, so that means 6x is going to be in the denominator. Then you're going to multiply by the natural log of 5, or 1 over the natural log of 5. So it's down to a or d, because remember that natural log of 5 is going to be in the denominator. And then you'd multiply by the derivative of what's inside. In this case, it would be 6. So A is your correct choice. Oh, I did that too fast. Let me work this problem out. Sorry, I probably missed some little detail. Y equals log. Oh, I know what I did. I forgot to multiply by 6. Okay, y equals log 5. Well, let me see what I did. I multiplied by 6. Log 5, 6x. So let's do this slowly. So the derivative, first you take 1 over 6x. That's what I did. I forgot to cancel the 6's. And then you multiply by 1 over the natural log of 5. And then multiply by the derivative of what's inside. And that's where I made my mistake. I forgot this 6 here. Okay, there we go. That's better. So lesson learned, take your time. You have plenty of time to do the test. Don't rush like I'm trying to do right now. So x ln 5. There we go. That's much better. And notice how they were, my answer was there. So that's another reason to be careful, is because they know the common mistakes that people are going to make, like I did here. So there we go. That's better. Okay. Here you can see the 3 steps. Okay. Copy. This is exponential, by the way. Copy what you see. So 7x to the 4th, 7x to the 4th. It's all in every answer. That's for step 1. Step 2, multiply by the natural log of the base. So there you can see natural log of 7, natural log of 7. These 2 are out because they're missing natural log of 7. So it's down to C and D. And then the last step is to multiply by the derivative of the exponent. Well, that's 4x cubed. So you can see the 4 there and the x cubed there. So C is the correct answer. So know those 3 steps for differentiating exponential functions, and then the 3 steps for differentiating logs. Make sure you know those. Okay, we're getting down here to the wire. We've got 6.1, pretty simple section to do. All you're doing is plugging in numbers. So I'm not going to do both of these just to save time. We have f of xy, and we're given x squared minus 4xy minus y squared. Don't miss this problem because it's so simple. And why not? Don't give up points like that when you have an easy problem like this. We're asked to calculate f of 5, 0. So all you're going to do is recognize that this 5 is x and this 0 is the y. So you're just going to plug in 5 for x. So we got 5 squared minus 4 times 5. Y is 0, right? So I'm going to multiply that by 0 minus 0 squared. So this is 0 because anything times 0 is 0. This is 0. All you've got is 25. See how simple that is? Don't miss this problem. All right. Oops. What did I do there? Okay, 25. There we go. All right. I'm not going to do this because it's so simple. You already know how to do it. Here, same thing. Don't be bothered by e to the 5. E to the 5 is just another number. When you take the natural log of e to the 5, the natural log kind of cancels with the base e. So it's just plain old 5. And you can do that on your calculator if you don't know that. So it's going to be 5 plus 6 cubed. I'm not sure what 6 cubed is. Is that 216? Let me just check. 221. Let's see. The 6 cubed, let me see, 36 times, yeah, that's 216. Plus the 5 is going to be 221. Okay, so see how simple this is? Use your calculator if you have to. You need to know how to find the domain of a log function. So I'm going to just do one example here. If it's under the radical, you've got to have that greater than or whatever's under the radical, that's called the radicand, it must be greater than or equal to 0. So in this case, we have 5 plus y has to be greater than or equal to 0. So the domain, let me just write this down real quick. We have 3x e to the square root of 5 plus y. So you're going to set 5 plus y greater than or equal to 0. You're going to subtract 5 from both sides. So y has to be greater than or equal to -5. And you can see in your choices here that right here, D is the correct choice. Okay. Here, same thing. You just set y plus 4x greater than or equal to 0. So you're just going to say, I wonder, you can just write 4x greater than or equal to 0. That's simple. Here you want your denominator not to be 0. So you're going to have 4y. If you set 4y plus 2x squared equal to 0 and solve that for y, you're going to subtract 2x squared from both sides. And then you're going to get 4y is equal to -2x squared. And then you're going to divide by 4. So you want y not equal to, this is going to cancel. So you're going to get -x squared over 2. So you don't, because the denominator equal to 0, we don't want it to be equal to 0. So you're going to say not equal. And I think that's the way they have it set up there. So you're just going to type in -x squared divided by 2. Okay, so these are really simple. Now it takes us to 6.2 on partial derivatives. I'm kind of running out of time. If you have to go, you can go, but I'm going to just continue here so that we can finish up. 'Cause I want to, I went over this very carefully in class last time, so I don't want to spend too much time on it. But let me just do this example here. We have z equals negative x cubed plus 3y squared minus 8xy. And we were asked to find the partial derivatives dz dx, dz dy, and then we were going to evaluate those at the point 5, 0. I may have already done this problem actually. But anyway, so dz dx, the way I recommend you do these is if you want to bring a red pencil with you to the test, what I would do is when you differentiate with respect to x on these partial order derivatives, this, by the way, is section 6.2. When you do that, go ahead and highlight your constants in red. So we're differentiating with respect to x, which means y is going to be held constant. So when I write this, I want, I have negative x cubed, and then plus, this whole thing is constant, 3y squared. And then we've got minus 8y x. Okay, so there's the x. I put the 8y together because those are being held constant. Now we're differentiating with respect to x. So what this is going to look like is negative 3x squared. This is constant because it's in red. So it's going to be, the derivative of that is 0. Here, we just have a constant times x. So the derivative of that is minus the constant, or, constant, minus 8y. And there you have it. Okay, now you want to differentiate with respect to y. And so this time you're going to highlight the constants, including all the x parts. So here we're going to write this as negative x cubed plus 3y squared minus 8x y. Okay, so there you have, to take the derivative of this one is 0 because that's constant. It's in red, so I treat it as a constant. Here we have a constant times y squared, so it's going to be 6y. Okay, my husband's calling me, 6y. And then here you just have minus 8x times y. It's just going to be minus 8x. So go ahead and I didn't get to all of the problems, but let me just double check and see if there's anything else. Then you just, for these two parts, you just plug in x equal 5 and y equals 0, just like we did from section 6.1, just plugging them in. I went over, like I said, in class, if you check that recording, I went over very carefully the how to do these partial derivatives. So you might check that out since I didn't really finish here. I did a lot of these types of problems, I think, in there. Here's the same thing, just multiple choice. So, and when you have two variables, again, it's really just the same as one variable. You set the denominators not equal to 0. So this would mean y is not equal to 0 and y is not equal to -5. So C is the correct choice. There you just set x minus 8. And here's just an application problem from 6.1. You're just plugging in numbers. So here we're given a function. Don't be bothered by the fact that it's a word problem. It just says if the ranch has 75 acres of alfalfa and 60 acres of grass, how many cows may graze? So just say X is the number of acres. So you just plug in 75 for X. Y is the number of alfalfa acres, and so you just plug in 6, or wait, it's the other way around. X is the grass, Y is the alfalfa. So it goes, X is 60 and Y is 75, and you just plug those in and into your calculator, and that's how you do that one. Same thing here, you just plug in the price and the E and do your calculation. P divided by E. So you're going to take 240 divided by 32.8. Okay, so real simple. Yeah, same thing. So I think pretty straightforward. I am not going to put any of the second order partial derivatives on the test. Here they want you to find fxy. That's a second order partial derivative. You can do those problems, but I'm not going to put the second order partial derivatives on the test. I'm just going to do first order. So the last 3 problems, don't worry about those, but you can do them for extra credit. Okay, so that covers it. And I will post those links to you today so that you have them to study with, the videos to study over the weekend. And I hope you have a great weekend. See you on Tuesday.